In this course, you will identify the ideas, practices, and policies that constitute the concept of sustainable agriculture. Industrialized agriculture practices which have been used over the past several years have significant drawbacks by damaging the environment and reducing food quality. These include topsoil depletion, groundwater contamination, air pollution, greenhouse gas emissions, the decline of family farms, neglect of the living and working conditions of farm laborers, new threats to human health and safety due to the spread of new pathogens, economic concentration in food and agricultural industries, and disintegration of rural communities. As a result, it is an urgency to implement systems that do not have negative effects on environmental goods and services, which satisfy nutritional needs and are accessible to and effective for farmers. To be more specific, scientists and farmers need to develop innovative methods that could reduce or eliminate many of the costs of industrial agriculture and still allow farmers to run a profitable business. Today, this movement for sustainable agriculture is gaining increasing support and acceptance within the food production. As a result, it is an emergency to implement systems that do not have negative effects on environmental goods and services, satisfy human nutritional needs, and are accessible to and effective for farmers. Today, this movement for sustainable agriculture is gaining increasing support and acceptance within the food production. Sustainable agriculture lays on the principles that we must meet the needs of the present without compromising the ability of future generations to produce and flourish. Practitioners of sustainable agriculture seek to integrate three main objectives into the work: a healthy environment, economic profitability, and social and economic equity. Every person involved in the food system, growers, food processors, distributors, retailers, consumers, and waste managers can play a role in ensuring a sustainable agricultural system. The rest of this presentation delves further into the practices underpinning sustainable agriculture and sustainable food systems. Growers may use methods to promote soil health, minimize water use, produce power in an environmentally friendly way, and lower pollution levels on the farm. Soil erosion continues to be a serious threat to our ability to sustainably produce adequate food. Numerous practices have been developed to keep soil in place, which include minimal tillage systems, managing irrigation to reduce runoff, keeping the soil covered with plants or mulch. By this way, farmers can reduce the growth of weeds and conserve soil moisture. Increase the soil organic matter through the integration of crop residues and animal waste into the land. Organic matter used as fertilizer has been found to improve soil structure, increasing its water holding capacity. In many parts of the world, water for agriculture is in short supply and/or its quality is deteriorating. Several steps should be taken to limit water mismanagement, which are improving water conservation and storage measure. As an example, many farmers have built their own ponds to capture and store rainfall for use throughout the year. Selection of crop species with lower water requirements, use of reduced volume irrigation systems, and use of methods which reduce water loss. As an example, monitored network activities and quick repair. Modern agriculture is heavily dependent on non-renewable energy sources, especially petroleum. To mitigate climate change and reduce greenhouse gas emissions, there is a need to substitute non-renewable energy sources with renewable sources. Despite the site-specific and individual nature of sustainable agriculture, several general principles can be applied to help growers select appropriate management practices. Selection of species and varieties that are well suited to the site and to conditions on the farm. Factors such as soil type and depth, previous crop history and location should be taken into account before planting. Pest-resistant crops should be selected which are tolerant to existing soil or site conditions. Using crop rotation systems, it can be used to suppress weeds, pathogens, and insect pests. Management of the arable soil to sustain its fertility and productivity. minimizing chemical inputs that harm the environment on farms and in rural communities. The goal is to develop efficient biological systems which do not need high levels of material inputs. Farmers that can reduce the use of toxic pesticides by planting more diverse blends of crops and bringing natural enemies like the spotted beetle. The selection of the animals must be appropriate for the farm's or ranch's resources. For example, ruminant animals such as cattle or sheep cannot be raised in less favorable environments with sparse or highly seasonable forage growth. In this case, hardier breeds should be selected. Using methods that guarantee the animal's welfare, monitor animal conditions and performance. Animal health is the key to successful livestock production. Food waste occurs in all stages of the food supply chain. As the production of food is resource intensive, food losses and waste are indirectly accompanied by a broad range of environmental impacts, such as soil erosion, deforestation, water and air pollution, as well as greenhouse gas emissions that occur during the processes of food production, storage, transportation, and waste management. As a result, reducing food waste is a priority along the food system. There are many practices to prevent food waste, such as relaxing cosmetic standards and spreading consumer awareness of the relationship between product appearance and quality, improving relations between farmers and retailers. Retailers can be more forthcoming in sharing forecast data for specific food items to help farmers with the production planning and prevention of overproduction. Use of packaging that ensures a long-lasting product. Misshapen produce, which cannot be marketed because it does not meet the common market specifications, can be used in another way. It can produce jam, chutney, and syrup out of non-used fruits, vegetables, and herbs. Improving storage and preservation methods. Use of recyclable packaging materials. In conclusion, not only does sustainable agriculture address many environmental and social concerns, but it offers innovative and economically viable opportunities for growers, laborers, consumers, policymakers, and many others in the entire food system because it respects natural wildlife and biodiversity. It promotes energy efficiency of farming operations. It prevents pollution of soil, water, and air. It promotes education for both farmers and scientists. It encourages innovation. It reduces financial risks for farmers, and it focuses on the rejuvenation of rural communities.